Welcome everybody. Today we're going to be looking at a rock cycle diagram. We're going to create a diagram that shows us how sedimentary rocks forms. We're not going to do the entire rock cycle diagram because there's way too much information to take in all at one time. So we're just focusing today on one rock type, sedimentary rocks. So to do this, what we're going to want is just a standard sheet of paper. We're going to turn it sideways, like widescreen version. And as we draw this diagram, we're going to learn a lot of vocabulary words, and we're going to focus on a lot of the processes that form different rocks. So at the top here, we'll put in a title.
We can't see.
You will. The rock cycle. It's called a cycle because different types of rocks can transform into other types. The rocks that are on Earth are constantly recycled, changed into different rock types. Sometimes a rock could change into another type of rock like almost in a split second. There are pretty intense things that happen that could transform a rock like instantaneously. For example, when we do metamorphic rocks, you're going to see how a meteor or an asteroid could crash into the Earth, and all that heat and pressure would instantly transform a rock from one type to another. Other times, it's going to take potentially millions of years for one type of rock to turn into another. But the cool thing is that rocks are constantly cycled and changed. So we'll see some of that today. We're focusing just on sedimentary rocks today. And you'll see that a lot of the action of the rock cycle happens below ground. Sedimentary rocks tend to form close to the Earth's surface. And the cool thing about sedimentary rocks, since they form close to the Earth's surface, they capture and preserve a lot of details that you would not find in other rocks. So I'll show you an example of what I'm talking about. We just recently got a gift to our science department. It's a very cool fish fossil. Now, I don't have a lot of information of how old this fossil is, what's the exact species of fish, but since this fish died and fell to the bottom of a lake or an ocean and got buried in mud, it was preserved. If you had a dead fish laying on the bottom of the lake, it wouldn't be there very long till something would come eat it, right? But since a bunch of sediment was washed in and deposited over the top of this, it was kind of locked away. It was preserved. And you can see just incredibly fine details like the fin bones. You can see like the gill plate, all kinds of stuff. Tiny little bones and details are preserved. We're going to find that in sedimentary rocks. Would you ever find a fossil in a metamorphic rock?
No.
Why not?
It would just be pressure and heat up.
It'd be crushed and deformed. What about, would you find a fossil in igneous rock? Right, because when it melts into lava, boosh, there goes your fossil melted away. So that's why I really like sedimentary rocks. They preserve a lot of details. And this particular rock type that we see here, this is called shale. It formed from layers of mud that got hardened into rock. So we're going to see that today as one thing that could form. So I'm going to move this fossil and go back to our diagram. All right, so when we draw, today we're focusing on really surface processes that are going to form sedimentary rock. And what I'd like to do is, first of all, just draw the landscape and then wait till I've got that drawn before you start your own. Okay, I'm going to start up here. We'll want to have like a mountain peak with a cool cliff face, a little flat area, and then we want to let that drop off into like a lake. And then over here, a little flat bench. We're about halfway across the page. And I want to throw down a crater. Because like I said, when we get to metamorphic, we're going to show a meteor asteroid crashing into the ground. And then over here, on this side of the page, we want to draw a really cool, like broadly sloping volcano. So when we talk about igneous rocks, we'll get to see what goes on to form those. So that's your general landscape. If you notice, I've got about half of the space of my page empty down here for underground processes. And then we've got a lot of room up above still to show what's happening above ground. So take a minute, draw on your landscape. You'll probably want pencil because we'll be erasing parts of this. Of course, since we're doing a diagram, we want to add color. That gives us a lot of opportunity to show details. If you don't have colored pencils, there's some on the front table, or you could come quietly get some and move back to your desk. So, for starters, we've been watching this show called Ice Cold Gold. These people are exploring in Greenland. And that's kind of something we want to keep in mind, because the people who are working in Greenland, they were working around lots of active glaciers. So we're going to throw an ice cap on top of the mountain. And their work was very dangerous because all the rock is broken apart and it's loose and it's collapsing in landslides and rock slides. There's all kinds of loose boulders. It's pretty dangerous stuff. That's how we're going to start our rock cycle. We're going to show that especially high in the mountains, water is going to get into cracks. I'm going to make a little crevice in the mountain here. And if we had meltwater coming off this glacier, for example, and it flowed into the crack, it would freeze. When water freezes, it expands. It expands about 8 or 9%. This is why in Minnesota we get potholes in the fall. We get potholes because during the daytime, the snow and ice on the road will melt. It'll flow into small cracks in the sidewalk and the pavement, and then at nighttime it freezes. And when it freezes, it pushes or wedges apart the crack and makes the crack bigger. And if that happens over and over, that freeze-thaw action, you can basically take solid rock and completely fracture and break it apart. So we're going to show that this mountainside is getting cracked and broken apart into smaller pieces. And let's put a few jumbled up broken rocks right here. So the first process that's going to start to form sedimentary rocks, we have to break solid rock apart to create sediments. So the process of breaking rocks into smaller pieces is called weathering. So that's our first term, weathering. Weathering. And once rock is weathered or broken apart, we've created sediment. And really, sediment could be something the size of a boulder, all the way down to just a speck of dust. So what do you think is going to happen to this loose pile of sediment that's like precariously perched on the mountainside? What do you think, Maya? It's going to collapse. It's ready to go. So what I would like to do is show like a piece of this rock that has like tumbled off, and it's going to bounce and drop in here. And I want to show like a gust of wind that comes along and blows some dust and sand around. And that dust and sand is going to also find its way in to our lake. So here's our lake. So we broke rocks apart through weathering. We created sediments. And now the sediments are moving. There's a word for that when sediments move around. It starts with an E. You might have learned it last year in 8th or in 7th grade. Like if you talked about farmland losing soil over time. What is this word for moving? What is it, Autumn?
Erosion.
Erosion, very good. Erosion. And some people actually will confuse these two terms, weathering and erosion. Oftentimes people say, oh, the rock's getting broken down, it's eroding. Well, It's actually weathering when it's breaking apart. But a lot of times, as soon as rock weathers, it's going to start to move. So weathering and erosion kind of go hand in hand. We just want to make sure we know that weathering is breaking rocks down, erosion is moving the rocks around. And when they get to a spot where they can settle out, that's what they'll do. What do you call it when you put money into your bank account? It's not a withdrawal, it's a deposit. Thank you. Yeah, so the term for sediments that are getting dropped somewhere is deposition. D-E-P-O-S-I-T-I-O-N. Deposition. And a lot of times these sediments are going to be deposited in nice flat layers. You would have a mix of stuff. You'd have some rocks here that deposited in. You'd probably have some sand that fell in there. You'd probably have some layers of like mud. Is that a rock yet? Did we create sedimentary rock yet?
No.
No. We just have like a loose pile of sediments. We got to turn it into rock. So to show this part, how that sediment gets turned into an actual rock, we're going to have to zoom in a bit. So what I'd like to do, I'm going to draw a red box right around this area. And we're going to zoom in. So we're going to bring an arrow over here, and we're going to zoom in on that. We're going to show a zoom view. A geologist is going to be able to tell you, based on the shape of the sediment, if it came from very close by or if it traveled a long distance through erosion. If the sediment chunk didn't move very far, it would still have some sharp, like jagged angles to it. So we could have some sediment in here that has some sharp edges. It didn't travel very far from its source. Not much erosion happened. The grains of sediment wouldn't lock together very, very well. There would be open spaces in between. Now let's say that we had some sediment washed in that came from a far distance away. Sand is going to be a good example. If you were to look at some sand up under a microscope, it would be very rounded. And that would show that it traveled a long distance from its source. So we'll have some rounded grains in here too. Can you pack round things together very well? I have a jar of marbles that I like to show sometimes. They don't fit together very well. There's always open space. So let's go about like that. So we got a few layers of sediments that dropped in. We have spaces in between. And up here, since we zoomed in right here where the sediment's being deposited, we're going to have water that's sitting on top. Do you think that's pure water? Like pure H2O? Kels, what do you think? Is this pure water?
I don't know.
Pure, fresh H2O, nothing dissolved in it at all. What could possibly be dissolved in there? What's that? Things. You ever been up to like the North Shore area up by like Duluth and looked at a stream?
Fish pee.
There could be fish pee. Yes, very good. But I was thinking more along the lines of minerals that were dissolved. And in Minnesota especially, we have a lot of iron in our water. So what I'm going to do in this water up here, I'm going to draw some little brown dots that sort of look like iron oxide. Lake Superior doesn't look like nice blue water up close. It looks like root beer. It's got so much iron in it. So we've got a lot of minerals that are dissolved in the water, and since there's open space between our sediments, the water's going to flow down in there. These open spaces are called pores. Just like the spaces in your skin are called pores. You have little openings in your skin called pores. So water's going to trickle down into these pores. And not just water, but the minerals too. Notice I didn't color in my bottom ones just yet. So what's going to happen over time as more and more sediment washes in and piles up? What's going to happen to these layers down at the bottom?
It's going to get packed together.
It's very good. It's going to get packed together. The word that we'll use for that, it's another sedimentary rock process, is compaction. Yeah, it's going to be compacted. And as those sediments pack down, it starts to squish water out of the pores. That's the first step in forming a solid rock from a pile of loose sediments. We have to squeeze out some water. But the other thing is, anytime you've got an open space, crystals like to grow there. Like, have you ever seen a geode? Like a rock that's cracked in half with crystals inside? Mineral crystals like to fill in open spaces. Or a petrified bone or petrified wood. It doesn't have, it's a lot heavier because it doesn't have open pores in it anymore. That's all been crystallized with minerals. So let's show along the bottom that some iron oxide or rust has filled in these pore spaces and glued the sediments together. I'm going to use a mix of red and brown as I color this in. In general, any type of mineral that fills in a pore space is called cement. That's the generic term, cement. And you could have iron oxide cement if you found rocks in northern Minnesota. You could find calcite cement. There's a lot of different minerals that could grow and cement the sediment grains together. And that process of growing cement is called cementation. So let's recap. They say a picture's worth 1,000 words. I think we can do it in less than 1,000. So the rock cycle is a process where one type of rock can turn into others. For example, this mountain up here, that's probably like metamorphic rock. A lot of times mountains are formed from big forces. A lot of pressure going on. So we could have metamorphic rocks here or igneous rocks. This could be a volcanic mountain that's breaking apart. You could have any type of rock up here. It's getting broken apart through weathering to create sediment. The sediment moves around through erosion and eventually becomes deposited, a lot of times in bodies of water. Once the sediment is deposited, it becomes compacted. The water starts to get squished out. Mineral cement can start to grow into the pores. And boom, we've made solid rock. We made sedimentary rock. There it is. Boosh. So what I'd like to do next, I'd like to go ahead and draw 5 different types of sedimentary rock that could form. And this is what's kind of cool about geology. Geologists will draw symbols to represent different rock types. And they're like universal symbols that represent the same thing, regardless of which country you're in or language you speak. These rock type symbols tell you what type of rock it is. So we're going to draw 5 layers. 1, 2, 3, 4, 5. Okay, our first rock type. Let's say we had a whole bunch of grains of sand that washed in. All sand. The symbol we use is just a bunch of dots. And that type of rock, if it got compacted, cemented, would be sandstone. Who did a rock types world tour project like Rainbow Bridge or let me think of another one. Rainbow Bridge, Monument Valley. Carly did? Yeah, that was sandstone.
Yeah, Rainbow, like how the arches were made is like the wind would just kind of like roll the sand, and it would like be like kind of like a wall, and it would just kind of slowly form and stuff.
Yep. So sandstone, a lot of times, if it's not cemented together very well, sandstone that's not cemented will still have a lot of open pores, which is cool because that means water could soak into it. It could hold a bunch of water, or it could even hold oil. It could hold a lot of things. Sandstone that has a lot of open pores is porous. Things could soak into it, and it's also not very strong. You could like scratch into it, carve your name into sandstone. But if sandstone gets cemented together, then it becomes a lot stronger. We saw, especially in the desert Southwest, a lot of the sandstone structures there are kind of a reddish-orange color. So I'm going to shade my sandstone in with some yellow and then cover it up with some orange to show that kind of cool sandstone. There we go. First rock type, sandstone. All right, let's do our second rock type. We saw that fish fossil. What was that rock made out of? That fish, the type of rock that trapped the fish. What was that made out of? What kind of sediment? It was called shale. You're right. But what actually made that? Was it sand? No, it was layers of mud. So shale comes from layers of mud. They get compacted and eventually turned into rock. So to draw this one, we just do like overlapping lines that show like layer after layer of mud washing in. That would be shale. The shale we saw is kind of a tan color, but a lot of times shale is shown as kind of a bluish green or gray color. So I'm just going to try to do like a little bluish green action. And there's our shale. There's another type of rock that people oftentimes mistake for shale. They look pretty much the same. Shale is made of mud, which is like the finest type of sediment, clay and mud. But there's another very fine sediment. It's called silt. And silt is like mud, but it's a little bit gritty too. So to draw a silt stone, we would draw this, like a layer of mud and then a little fleck of grit. Mud, grit. Mud, grit, mud, grit. It almost looks like you're writing Morse code. Help, I'm trapped in science and Mr. Olson took my phone. There we go. That type of stone would be silt stone. Siltstone. A geologist can tell the difference between siltstone and shale, and here's how you do it. You take a tiny nibble off the rock, and you crush it between your teeth. And you rub your tongue across it. If it's totally smooth and creamy texture, it would be shale, pure mud. If it has a grit to it, it's siltstone. I've done it. Either way, it's going to taste really weird, right? Geologists do weird stuff. Sometimes they'll lick a rock so that they can see the surface and crystals. Sometimes they'll take a little nibble to tell the difference. That's the field test right there. All right, we got two more types. Did anybody do the Great Pyramid of Giza? Or I mean the Sphinx. The Sphinx, yes.
What color is she?
Oh, siltstone a lot of times is left white. Okay. So back to the Sphinx. Maya and Kenny, what type of rock was that made the Sphinx? It was limestone. That's a sedimentary rock. Limestone forms in shallow water when crystals form, and they usually form really thick layers. So the limestone symbol looks just like the wall in our classroom over there. It looks like layers of bricks. So we're going to divide this layer into two. We're going to draw some staggered bricks. The symbol is supposed to represent that limestone can grow in really thick sheets, just crystallizing one on top of the other. This could be hundreds of feet thick. And a lot of times you might have fossils that are trapped in there too, since it's an ocean type of stone. Limestone. And the color is really kind of a tan color, so I'm going to use peach. I've got a peach. If you have tan, that'd be fine too. All right, guys, that brings us to my favorite type of sedimentary rock to draw. I don't have a favorite type of rock to eat. So here we go. Favorite type to draw? It's kind of cool. It's kind of random. If we had a layer of rock where a whole bunch of stuff got mixed together, you might have something called a cobble. Cobble's big, probably like 3 inches or more in diameter. They could be very big. So let's put some cobbles in here. Let's say we got some cobbles that dropped in. You ever heard cobblestone streets? Yeah, those are cobbles. You can picture how big they would be. We could have pebbles. A pebble is something you might put into a slingshot or throw at your brother and really not get into trouble too much. Your parents would say, quit annoying your brother. Oh, remember the pebble in the pond at our courage retreat? Okay, that's pebbles. Ethan, let's be respectful, please. We also would have some sand and some mud. So we can put in some little layers of mud here and there. And some sand. Now, this type of rock, we really want to show that it's made of a bunch of different rock fragments. We could have, for example, we could have some sandstone in there. So I'm going to color one of my cobbles orange and say, hey, that's a chunk of sandstone. Oh, here's another cool chunk of sandstone. We could have some shale that broke apart and got in here. So we could have a chunk of shale. We could have all kinds of stuff. You could have pieces of lava that hardened and broke off. You could have really lots of stuff. So we're going to color these pieces different colors. And then I'm just going to shade the whole thing in with kind of a yellow. The what? Yep, so the background, like all the sand and stuff. There it is. Now that type of rock has a cool name. I really like to find it because, I don't know, I've got some pieces you guys will see in our lab tomorrow. It's really cool looking. It's called conglomerate, CONGLOMERATE, conglomerate. Okay, so we got 5 types of sedimentary rock. And we showed all the processes that could form them. But there's actually one more kind of sedimentary rock process we should show. Do you remember when we drew our mineral formation diagrams? We said, hey, what if there was a shallow pond or lake that used to be up here and it dried up? What would happen to the minerals that were dissolved in the water? Kenny, what would happen? If the water dried up, what would happen to the minerals that were in the water? Yeah, they'd still be there. They would be deposited. So let's show that some of this water is evaporating. And I'm just going to use red. These crystals would probably be white crystals, like a sheet of crusty, almost like baking soda sometimes, or salt crystals. So that's the minerals that were left behind when the water evaporated. The general term for that, those types of minerals or rocks are called evaporites. E-V-A-P-O. Evaporites. All right, so I think we got a really good start. Are you starting to see why we broke this diagram into thirds? If I went on and talked about metamorphic rocks and all the things that were happening there, and then igneous rocks and all the things that's happening there, it'd be tough to keep that straight. So we're really going to just kind of tackle this in chunks, but your unit project will pull all of it together. So we're actually kind of done with our drawing for today, but we have to take some time and lock this information in by doing some definitions. We're going to do a little bit of vocab action. So for the vocab, this is the sort of thing that's going to appear on your quiz, right? We want to be able to learn the language of geology and use it. So I think the best way to do the vocab, some people try to do it on the back of the sheet, but trust me, there's like a lot. And we're going to do a little writing exercise tomorrow using the vocab that we learned. So let's just take out a sheet of notebook paper and we'll capture the vocabulary from today. And I think to help us really like review, let's kind of see it as we record the vocab. So we're going to be able to see the process here. Weathering is our first one. Breaking rock into smaller pieces. Weathering's breaking rock apart into smaller pieces. Ready for the next one? What do we call a piece of rock that broke off from another one?
Sediment.
Sediment, very good. So that's our next vocab word. Sediment, pieces of rock that have broken off of larger rocks. Who can tell me what erosion means? Kenny, go. Moving the pieces of rock, moving the sediments, yep. So there's a few different things we would call like agents of erosion, things that could move sediment, and we'll identify those as wind, water, ice, or gravity. which of those agents of erosion do you think is most active, like in Greenland that we saw?
Ice.
Ice, for sure. And then maybe secondary?
Water.
I'd go with water. Yeah, because that ice is melting and going everywhere. Yep. All right. Who's got, in your own words, what does deposition mean? In your own words, deposition. Auden, I bet you got this. What does deposition mean?
I really don't know.
So if you were going to explain it to like your younger brother or sister, you want to go, Auden?
Depositing the erosion into the water.
Sure. So like after erosion carries sediments, they get deposited into water. Sure. Yep. So here's what we've got. Deposition is when sediments are deposited, usually in flat layers and often in bodies of water. Notice I said usually flat layers, often bodies of water, but some of the coolest sedimentary deposits are in the desert where sand dunes were deposited by blowing wind. And when a sand dune turns into rock, the layers aren't flat, they're tilted. And oftentimes the sand dune kind of migrates back and forth as the wind switches direction. So you can have a bunch of angled layers that are in one direction and then angled layers that go back in the opposite direction. So it's not always flat, it's not always being deposited in water. There are other cool sedimentary deposits too. All right, so we've got a lot of processes. The last two processes are going to be combined. We're going to zoom in and talk about compaction and cementation. And this is really kind of a long definition because it combines both. So here's what we have. Compaction and cementation. Sediments are squished together by the weight of sediment piling up on top of them. As water is squeezed out, minerals grow in the open pores between sediment grains, gluing them together. Like I mentioned before, sometimes rocks are fully cemented. Every pore is full. But a lot of times it has open pores. And that's really important. If you're trying to pump water out of the ground, if you need to tap into a layer of rock that holds water, you're looking for a layer that does not have the pore spaces full. Of course, we study groundwater in a future unit, but we're going to see that having open pores that are connected to each other so the water can flow through the rock, that's very important if you're trying to pull something out. So if we're looking at groundwater coming out of a layer of rock, or people who explore for oil, they're looking for rock with a lot of pores that are open and connected. So oil, for example, could flow through there. So we'll get into that in a little more detail. It's important to realize that the pores don't always get cemented together. I think we might have one more term. Yeah. Holy cow. This is a long definition too, and this will be our last one for the day. Sedimentary rock is a type of rock that's made from sediments that have been compacted and cemented together. Or it could be made from crystals left from evaporating water. We should add one more. It could be made of the remains of organisms. 2. So coal is a good example of a sedimentary rock that's pretty much made from the remains of living things completely. That's a long definition. But it captures 3 different ways that sedimentary rocks could form. All right, I'm going to stop my recording. And if you need to keep working to capture the definitions, these definitions, the rock cycle vocab is loaded up in our Schoology unit, the unit called Rock Reader. You'll see it's called Rock Cycle Vocabulary. You'll see vocab for metamorphic and igneous rocks too, but don't move on to those yet. We want to learn those as we see them in action. So that's what we've got for today. Have a great day.